includes structure. It's been said that architects and engineers are the shapers of the built environment. They're visual thinkers, problem solvers, interpreters of their clients' needs. Today, much of this planning includes structures of concrete, and for good reasons. Because concrete has everything going for it. Concrete is beautiful. Concrete is versatile. You can mold it into monolithic shapes and forms. Concrete is economical. Today's better mixes and faster forming methods, speed construction schedules, mean earlier owner occupancy. With all these great benefits, concrete has one shortcoming, one problem: cracking. You've seen this happen on your jobs a few days after concrete has been finished. Distracting, worrisome cracks. Cracks that can grow into major problems with the job and with the owner. There is only one reason that cracks occur in concrete. A stress exists which exceeds the strength of the concrete at a specific time. However, there are many causes that contribute to the stresses exerted in the concrete causing cracks. These may be classified in two groups: structural, externally imposed stresses, which are a function of design and construction, and intrinsic, self-imposed stress, a function of the concrete itself. Intrinsic stresses that cause cracking are of three types: plastic, those occurring in the first few hours; thermal contraction, 1 day to 3 weeks; drying shrinkage, often several weeks or even months. Now, more and more designers are specifying a new product to control the problem of cracks caused by intrinsic stresses. For a solution is at hand. FiberMesh is its name, and its primary job is concrete crack control. FiberMesh stabilizes those intrinsic stresses, so elusive and difficult to control, particularly during the first 7 days when concrete is most vulnerable to shrinkage cracking. Produced as fibrillated bundles, FiberMesh is used in concrete at 1.5 pounds per cubic yard. FiberMesh is a fiber engineered strictly for concrete construction. Made from virgin polypropylene, manufactured exclusively for FiberMesh by its sister company, Fibron Corporation. The Fibron fiber is precisely sized and shaped to inhibit concrete shrinkage cracking. The mixing action causes the engineered bundles to open and separate into millions of individual fibers. These individual strands are uniformly distributed throughout the mix in a multi-directional system. As the mixing water begins to exit concrete, small micro cracks start to form. At this stage, the tiny cracks possess very little energy and are easily arrested by blocking the crack with a fiber. As micro cracks occur and intersect with the FiberMesh strand, their propagation is halted. They are stopped in their tracks. This is the function of FiberMesh. With millions of FiberMesh fibers distributed uniformly throughout the concrete, micro cracks can't develop into macro cracks. Actually, the concept of using fibers to promote dimensional stability goes back to Roman times. Horsehair was added to the mortar used in the construction of the Colosseum. There are many tests that confirm the ability of FiberMesh to inhibit concrete shrinkage cracking. In a study that included a wide variety of concrete materials, Paul Cry, a civil engineer and concrete specialist, conducted a thorough series of tests at the University of California, Berkeley. The tests accelerated environments which cause cracking due to concrete drying shrinkage. The setups simulated conditions of high temperature, low humidity, and controlled wind velocity. The photo on the left is a control slab without fiber mesh, taken at 24 hours. Note the fine cracks visible on the surface. The slab of the same concrete, but containing fiber mesh, did not show any cracks during the same time span. Here are the same two slabs at 28 days. The control slab has slightly more noticeable cracks and enlargements. The fiber mesh slab shows no cracks. The studies confirm a consistent reduction in cracking due to drying shrinkage of 90% to 100%. Because of this substantial reduction in the formation of shrinkage cracks, the fiber mesh method is far superior to the use of welded wire fabric as a method of controlling concrete cracking. The use of wire mesh does not stop concrete from cracking. It merely contains the cracks. Fiber mesh inhibits the formation of cracks in addition to containing the occasional crack that may appear. Seeking additional evidence on the performance of fiber mesh concrete, we commissioned the well-known firm of research engineers Wyss, Janney, Elstner to do a comprehensive series of tests. The purpose of this test program was to compare, on a large scale, the flexural capacity and deflections of a concrete slab containing a normal dosage of fiber mesh polypropylene fibers to a plain concrete slab and a concrete slab containing a typical amount of welded wire fabric used for drying shrinkage crack control purposes. We wanted to confirm that fiber mesh concrete is a practical alternative in all respects to concrete containing welded wire fabric when used for shrinkage crack control. 3 10-foot by 10-foot concrete test slabs were cast from one batch of concrete, a 4,000 psi mix. After 28 days of curing, each slab was elevated. Force was applied in 1,000-pound increments and continued until failure. Results show the fiber mesh slab outperformed the plain concrete in flexural load capacity by 8% and the wire mesh by 2%. Quoting directly from the conclusion of the official report, the flexural load capacity data indicate that with respect to flexural response characteristics, fiber mesh can be used as a practical alternative to welded wire fabric, which is commonly used for shrinkage crack control purposes. Let's consider which alternate is more practical for today's faster pace of construction: welded wire fabric or fiber mesh. As you can see, with fiber mesh, we have equivalent properties in every direction. All the concrete is protected against cracking. Compare this with the single plane contribution provided by wire mesh. Areas above and below are left unprotected. By eliminating wire mesh, you expedite construction and save on problems. Wire mesh is time-costly and cumbersome to install correctly, requires multiple handling and hoisting equipment. It's hazardous to foot traffic during placing operations. In parking areas and concrete paving jobs, mesh placement on chairs prevents the use of the subbase to transport concrete, slowing progress and increasing costs. Now, here's a site that mars both aesthetics and client relations, caused by rusting welded wire fabric. Fiber mesh is clean, safe, lightweight, becomes an integral part of the concrete. It's non-corrosive, can't rust or rot. It's chemically inert. Fiber mesh is added to the concrete mix at the batch plant or to the mixer at the job site. It's handled just once. The uniform distribution of FiberMesh concrete is easily accomplished by the mixing action. The Wyss-Janney-Elstner tests also confirmed typical strength comparisons with plain concrete. FiberMesh concrete had an 8% increase in compressive strength over plain concrete. 6,300 average PSI for FiberMesh concrete compared to 5,900 average PSI for plain concrete. Modest increases in flexural and tensile strength were also typical of FiberMesh added value. Another test area we should examine are the results of a recent study that can be of vital concern to you as a concrete professional. The shatter resistance of concrete is increased with FiberMesh. Now, you can appreciate the benefits from this feature in jobs where impact or seismic conditions should be considered from a safety standpoint. This series of investigations was ordered to compare the shatter resistance of plain concrete versus FiberMesh concrete when exposed to crushing loads. Conducted by Paul Cry in the laboratories of San Jose State University, specimens simulating a building column were tested under compressive loading. Here, both specimens have been compressed 1/10 of an inch. Both have tolerated first crack, and the plain concrete specimen on the left is beginning to spall. Now, just under 1/3 of an inch, both specimens are showing the effects of the crushing action. But no concrete has spalled from the FiberMesh column on the right, contrary to the accumulation at the base of the control column on the left. Applying just a bit more squeeze, the plain concrete column totally ruptures at 32/100ths of an inch compression. Not so with the FiberMesh concrete. The test machine continued to compress the column, going to 1/2 inch and to 1 inch. The FiberMesh concrete column is still solid, still holding. The crunch continues to a full 2 inches of length reduction. This was the limit of the printout recorder. The specimen now was reduced by 10% of the original column height with only an insignificant amount of concrete freefall visible at the base. When the platen was raised, the FiberMesh specimen was still intact and freestanding. No collapse and minimal spalling. This is a close-up of FiberMesh strands in the test column demonstrating their anti-shatter action under compressive loading. FiberMesh is unique. Its engineering performance reflects years of research and development, which continues with the industry's most extensive program. A case in point, FiberMesh has embarked on investigative programs with laboratories and universities to do in-depth studies of the overall performance of FiberMesh in concrete. This undertaking, coupled with other programs underway throughout the country, confirms the role of FiberMesh as the industry leader. Now, let's discuss impact resistance, a FiberMesh added value. The fibers have great energy-absorbing characteristics and act as tiny shock absorbers. Concrete is transformed from a brittle to a more ductile construction material. Confirming the results obtained in the laboratory was a study done in the field for the Quebec Department of Transportation by Canada Cement Lafarge's Applied Research Center. Here, fatigue and impact tests revealed a 3-fold increase in fatigue resistance and a 2-time gain in the impact resistance of FiberMesh concrete over plain concrete. For still more evidence of the contribution FiberMesh makes to concrete's impact resistance, a series of drop hammer tests were made. FiberMesh withstood twice the number of blows as plain concrete before developing the first crack. 5 blows for the control specimen compared to 10 blows for fiber mesh concrete. This kind of energy absorption is valuable for industrial plant and warehouse floors, highway barrier walls, and bridge parapets, and other areas where repeated impact can cause concrete distress. Permeability. It can be a serious problem with concrete. Reducing permeability is a major accomplishment of fiber mesh. This graph illustrates how fiber mesh has a favorable effect on the reduction of permeability of concrete. With fiber mesh, you can reduce permeability of concrete up to 79%, as indicated by the Vaughan test. Think about the importance of this fiber mesh benefit in projects like garage ramps and bridge decks, water and waste treatment plants, reservoirs, chemical plants. Another valuable benefit of fiber mesh concrete is that it's very pumpable, helping speed completions of projects like this parking garage. It's important to note that the test results reported in all these tests apply only to fiber mesh and its special Fibron fiber, which is engineered and manufactured exclusively for concrete use. We have covered these welcome benefits of fiber mesh: the ability to inhibit concrete cracking, greater impact and fatigue resistance, shatter resistance, lower concrete permeability. Altogether, they make concrete a vastly better building material while contributing to lower construction costs and reduced future maintenance. Rarely has there been a building product development that has had such rapid acceptance throughout the world as fiber mesh. Architects, engineers, contractors, owners, and developers have been quick to recognize its contribution to the construction scene. It's specified in projects of all types and sizes. Let's look at just a few. The 63-story steel-framed Allied Bank Tower, Dallas, with composite floor design utilizing fiber mesh. An office and retail mall in Natick, Massachusetts. Precast walls were fiber mesh reinforced to control spalling at edges. All floors and walks, 80,000 square feet, have fiber mesh. Spectacular River City near downtown Chicago. This mixed-use complex has 2,500 residences, offices, conference center, marina, theater, and more. Fiber mesh is used on upper decks and in lobby to control concrete cracking and reduce permeability. U.S. Postal Service addition to a general mail facility and bulk mail center in Springfield, Massachusetts. Over 4,000 cubic yards of fiber mesh concrete were placed. Houston is alleviating downtown traffic snarls with remote concrete parking areas served by express bus service. Fiber mesh is specified in these Metropolitan Transit Authority's areas. Omni International Hotel in Millender Center, Detroit, across from Renaissance Center, capitalizes on fiber mesh enhanced concrete. Over 750,000 square feet of it as topping over precast members. U.S. Navy helicopter pads, 8 of them, at San Diego base gained crack control and impact resistance with 3,500 psi fiber mesh concrete. The 2 to 3 inch slump concrete was also made more pumpable with fiber mesh. This large metro water treatment plant in Renton, Washington, has a 300 by 300 foot by 3 to 5 foot thick slab. Fiber mesh enhanced concrete was specified for shrinkage control, replacing a substitute method for very substantial cost savings. This new shopping center in Buffalo, New York saved $22,000 with fiber mesh concrete as a replacement for wire mesh. In a hurry to deliver a 340,000 square foot industrial plant? The design construct team for this 8-acre facility had a 105-day schedule. They fast-tracked the job, finishing well before deadline. FiberMesh contributed by saving on mesh handling and placement time. These few examples merely show a range of structures where designers have had FiberMesh included in the project specifications. You don't have to go back to the drawing board for any redesign work when you include FiberMesh concrete in your projects. Simply specify FiberMesh for all concrete roof and floor systems, decks, walkways, plazas, patios, parking areas, and other areas where shrinkage cracks, impact and shatter resistance, or permeability may be of concern. We hope this brief look at FiberMesh has been informative and interesting. As the world's largest producer of engineered synthetic fiber for concrete, you can be confident that your decision to specify FiberMesh will be a wise and rewarding one. Thank you.